Hey everyone, we just learned that spherical mirrors have a center of curvature and a focal point. In this video, we're going to learn about the significance of this focal point. So, the center of curvature is going to determine the focal point because the focal length, that distance, is actually half of the distance to the focal point. So, the focal length is just r divided by 2. Again, the focal length is a distance, the radius of curvature is a distance. Okay, well, who cares? Why do we need a point that is half the distance of the center of curvature? So, if we usually do this demo in class, but this is a really good picture of it. If you have a source of light here that is emitting parallel rays, then if those parallel rays hit a mirror, you can see all of these rays reflecting here, and they all reflect at the same point. That point is actually the focal point of that mirror. So you can see that there is something special about it, that these parallel rays reflect through that focal point. So that's what I have written here. Any rays initially parallel to the optical axis, and this line here that cuts through the center of the mirror, this horizontal line, is called the optical axis. Any rays parallel to this optical axis will reflect through the focal point. In addition, any rays passing through the focal point, right, this picture looks identical to this one, but in this one, you can see that the rays are coming from here, and they're going through that focal point. When they're hitting the mirror, they emerge parallel to the optical axis. This other ray here that is going through that focal point is emerging parallel to the optical axis. So I like to think about distant objects and relate those to the focal point. So this picture here shows that if you have an object very far away, then by the time the rays of light hit your point of interest here, those rays of light are actually very nearly parallel, right? Over here, you can see they really diverge when you're close to the source of light, but when you're far away, they're very nearly parallel. So, what this means is that we just saw that if rays are parallel and hitting a mirror, that they're going to reflect through that focal point. So put 1 and 1 together here, and what this means is that if you have an object very, very far away, so ignore this picture for a second. This picture was just to show you that rays are basically parallel. If you have an object very far away, let's pretend that this tree here is now your object, not this star. Let's say this tree is very, very far from this mirror, then that means that any rays that are hitting the mirror from the tree are nearly parallel to this optical axis, and they will reflect to the focal point. And wherever your rays intersect is where your image is going to be formed. Hence, the image of a very distant object is at the focal point. This was actually a lab that we used to do. We could see images formed at the focal point. So the understanding of this focal point will actually help us when we are drawing ray diagrams that will help us figure out exactly where these images are going to be formed.